Hello, gentlemen. Welcome to the second half of section 3.3 entitled Percent Composition from Chemical Formulas. Now, let's say that you are a forensic chemist and you're on the scene of a major crime and you see that there is an unknown substance all around throughout this scene. And you take a sample and you bring it back to your laboratory to analyze it. Now, how might you as a chemist analyze it? One way would be to take or find the percent composition of that substance, which is probably a compound or a mixture of compounds. Now, the percent composition of a compound is the percentage by mass contributed by each element in the substance. So we know that a compound is composed of different elements. The amount of mass that each element contributes to the overall mass of the compound is known as its percent composition by mass. We can find the percent composition for a given element by using this equation. We can say percent composition of the element is equal to the number of atoms of that element in the chemical compound times the atomic weight of that element that we get from the periodic table divided by the formula weight of the entire substance, so the entire compound, the overall mass of the compound. Multiply that times 100 to get a percentage of the composition of that element to the total mass of that compound. Let's do an example so we can clarify any questions you may have. So here's a question. Find the percent composition by mass of CH2O. That's the problem. Again, my percent composition of the element is equal to this formula here, which was described in the last part of the board. The first thing you want to do when approaching a problem like this is find the formula weight or the molecular weight of the compound in question. So we have CH2O as my compound. I want to find the formula weight. I do that by looking at the individual masses from the periodic table. I'm pointing to it now, but you can't see that obviously. But from the periodic table. So the carbon on the periodic table has a atomic mass of 0107 AMU. And I have one atom of carbon per my chemical formula. I add that to information on hydrogen. Hydrogen has a mass of 1.00794 AMUs, and I have 2 atoms of hydrogen. So I multiply this number times 2. 2 because of the atoms in my chemical formula. Oxygen has a mass of 15.9994 atomic mass units. I multiply that times 1, which corresponds to the 1 oxygen atom in my chemical formula. I add this up, and I get the sum of 30.0260 atomic mass units, which is the total formula weight or mass of that compound, CH2O. Now I'm going to take this number and use it in my percent composition problem. So to find the percent composition of each element, meaning how much mass does carbon contribute to the entire mass of my compound? That's the problem. Now, I do that by following this formula. So my percent of carbon, well, it's equal to the number of atoms of carbon, which is 1, times the atomic weight of the element that I gather from the periodic table. So times that, divided by the total molar mass, or molecular weight in this case, of my compound, 30.0260 atomic mass units. Multiply that times 100, I get 40.0010% carbon. So the mass of my substance, 40% of it is from carbon atoms. That's what this is saying. Now, for hydrogen, I have 2 atoms of hydrogen, multiply it times the atomic mass of hydrogen, divided by the total mass of my compound, or my chemical formula. Multiply that times 100, and I get 6.67377% hydrogen. So this percentage, around a little over 6% of my total mass of my compound is from hydrogen. Next, for oxygen. The percent of oxygen is equal to number of atoms of oxygen, 1, times the atomic mass, 15.9994 atomic mass units, divided by the total mass of the compound, 30.0260 atomic mass units multiplied times 100 yields that 53.2852% of the mass of the entire compound is from oxygen. If I add all these percent masses up, I will get around very, very, very close to 100, 99.99%. This is how you find the percent composition, meaning what percentage of these particular elements contribute to the overall mass of the compound in question, which in this case is CH2O. We'll do more practice this in class. Please take notes.